Hello friends, APIs are the backbone of current digital infrastructure, and today we are going to learn everything there is to know regarding APIs. So without any delay, let's get started. Now first let's imagine a scenario that you are currently hungry and you are planning to go to eat at some place in a restaurant. Let's assume that you go to this XYZ restaurant. So what would be the typical course of action is that one of the waiter who currently works at this XYZ restaurant would come to you. You would say that, hey, these are all the dishes I want to enter. That waiter is going to have a notepad or a tablet or something where that person is going to mark the entire order. And then that waiter will go to the background in the kitchen where you don't have access to go to that kitchen. That waiter is going to convey that this is the order, and the chef will start cooking and then prepare the meal. And maybe the same waiter or maybe some other waiter would be bringing back with your food, and then that food would be served to you. Now, why am I telling you this? You can think of this scenario as like a real world computer system or any particular software application. Now let's break down the characters. So number one character is you. You are actually a user in this case who wants to use the services that restaurant has to provide. Now let's assume this kitchen. Kitchen is actually the back end or the server of our computer system that takes in the order and prepares the meal according to the order and brings back or brings out the meal. This portion of the restaurant can be considered as the front end of the restaurant because this is where you are generally sitting. It is tend to be decorated and looks really good. Now in this case, user does not communicate directly with the kitchen. User communicates with the kitchen through the help of these waiters, and these waiters would be considered as APIs for our computer system. That's it. This is what an API is, and this is what an API does. It is simply there to facilitate communication between user or any particular system with the backend of our system. API is an abbreviation for Application Programming Interface. Now, as explained in the previous example, basically it is nothing but a communication channel between any particular user and any particular server. Now a user needs to ask for the different parameters from the server. Server needs to do a lot of computation and calculation in order to do that, and then server return back with the response. So this request response mechanism is typically handled by various APIs. Server is unaware that who the consumer or user is. It could be possible that there is a user who is actually requesting services from a server. It could also be possible that there is some another application, let's say XYZ, that also wants to communicate with the server and get or fetch all of these answers. In these case, both would be supported by various set of APIs, and these API definitions are actually created when we are designing our server, and that lets you define that, hey, these are the things that a server would want in order for you to process and give or return back the answers. Now let's start talking about the basic things, that why do we actually need these APIs. So think of our restaurant scenario. In a restaurant, do you actually want the users to directly go to the kitchen and ask for the stuff? No, right? Because then there would be a lot of issues. So same thing with the computer system, that providing user direct access to the main server that is actually performing all of the computation is actually very risky. So that is why there is a layer of abstraction created by APIs that ensures that only the secure parties or only person who is authorized can actually make the call. Number two, scalability issue. There can be n number of users who can start calling the services for the user or from the server, but they can all very easily be managed through the cluster of APIs. So that is the second issue. Third issue is that it allows user to grow. So how does it allow user base to go? Let's assume that we are a company like Google. Now we all know that Google provides like hundreds of services. What Google can say is that, hey, if you want to use my service, then this is the API that I created. Now for this particular API, I demand that, hey, you come in, you provide me these three items. And if you provide me these three items in the correct format, I would do the processing on my Google server in the backend. And because you provided me the correct information, I will provide you the correct answer. And that now, just because of this one API, all of these millions or billions of people, systems or applications, they can all start consuming Google services flawlessly. So Google does not have to worry about who is calling them or what is happening. So basically this is a normal progression for any particular application or company in order to provide their services to millions or billions of people. So these are some of the reasons on why do we need APIs. So let's first try to understand that what are common operations you can do with the APIs. Typically, APIs allows you to do these operations, that is get, post, put and delete. Now what does each one of them refers? It's very intuitive to understand based on its name, but we will try to understand it with using an example of Twitter. So let's assume that currently Twitter, this is the entire ecosystem of the Twitter. So Twitter does not care that who is the consumer calling them, as long as the incoming request comes in correct format and also that person is authenticated and authorized. Now let's assume that you wants to get some information. The information you want is that how many tweets you made in the last 6 months and all the tweet results. So what Twitter has is Twitter has an API called get tweets, okay, something like that, GT. Now for this tweet, it expects in the input that you provide the user ID for which you want all the tweets. On top of it, you also provide the time frame. So let's assume that you make a call, and then once you provide that, Twitter would actually consider this as valid incoming API and does all the processing it needs. And after completing the processing, it will provide you the information that you need. So get API means you wants to get some data. Same way, post means that you actually wants to write some data into the Twitter database. And in this case, let's assume that you wants to create a new tweet and you want to upload on your Twitter page. So what you would do is you would provide your user ID. On top of it, you would provide the new tweet that you are trying to make, and you would send this information to Twitter ecosystem. Now Twitter ecosystem says, okay, this is a valid API call. Let me provide or let me update this particular tweet for this particular user on my database. And once that is done, Twitter would say that, okay, or it will send back an API call with an acknowledgement that this task has been done. So get is to get some data, post is to post some data into the database or add a new entry. Put is modification of the existing entry. So let's assume that you created a tweet already earlier and now you want to make some change. So what you would do is you would create a put call with the previous user ID and the tweet that you already created and the new changes that you want to make. And once the Twitter updates that, it would send out a confirmation, and then you would know that at least your task has been done. And last one is delete. Delete is simple, that you want to delete some entry inside the database, and same thing would happen with the API calls. And all of these transaction facilitation is actually being done through APIs. So now you can imagine that how powerful these APIs are. Now typically there are actually 6 main types of APIs, but for the simplicity in this video we are only going to tackle the 3 main ones. And the number 1 is actually SOAP API, second one is a REST API, and third one is a little bit complicated and additional version of a REST API, and that is called GraphQL. So in this example, I'm only showing you these 3, but let me know in the comments if you want to see all 6, so I can probably make a separate video in the future. Now let's first understand that what does a SOAP API does. SOAP is nothing but a simple object access protocol. This API typically operates over HTTP or HTTPS. This is tend to be very secure API, and it also deals with TCP or UDP protocols. On top of it, it also works on the XML language, so extension markup language, and XML language is tend to be more rigid, and typically this is a little bit more complicated. This is a heavyweight application. So the question is that, hey, if it is rigid and if it is heavyweight, why do we actually use it? Well, the important part is security, that you can make any changes or transformation to the XML incoming request only in the secure manner, and this makes it a very good candidate for all the financial services. That anything you see like Stripe or PayPal, they all use SOAP based API in order to complete the payment. Second one is actually REST. So REST is a better version of SOAP based API, and REST is typically operates on the JSON language. So JSON is very similar to a human-like language that we can very easily understand. On top of it, the computers can also very easily understand this language. Not only that, REST APIs also, they are also secure, so they work on HTTP and HTTPS both protocols, and these are tend to be lightweight, so they can very easily be scalable to large number of volumes. And whenever you see lot of different companies, they are all mostly using REST API to expose their services. So companies like Google, Facebook, Amazon, you can name it, they're all exposing their services using a constant bunch of REST based services, where in the input you can complete all the operations we mentioned, that get, post, put, delete. You can do all of these things, and you can expose your API to a large volume of customers. So that is why this remains a very popular choice whenever you are trying to design your application. And the third one is actually a graph based or GraphQL API. Now there is something interesting about it. First of all, let me show you that how does REST and SOAP work. So typically there is going to be a client and there is going to be a server. And whenever you are making a REST based call or SOAP based call, basically the client is going to connect with the server is going to do some computation in the behind the scenes, and server is going to return back to client. So this is going to be one-on-one transaction, both of this for REST and SOAP API, but that is not the case in the GraphQL. So what does happens in the GraphQL is that let's assume that for any particular query, you are actually querying the server. Now you actually wants to get 5 different things from the server, and you know that server has the ability to provide these 5 things. So now what server will do is that server will take in this query. This is going to be a little bit more complex query, and it will take in the query with all of these 5 parameters, and then it will go to 5 different elements inside the given input, try to collect answer for each one of them, and after collecting all the answers that consumer has requested, then send back the answer back to the client, combining all of these 5 things. So it's not like that it is doing this or it is responding back in the 5 separate transactions. So you can imagine that GraphQL is a very powerful mechanism whenever you are dealing with the multiple data sets and you want to find items from various different places. The thing is, underlying infrastructure is still REST API, that these are still REST calls, but GraphQL is a query language that enables multiple queries to be bunched up together in a single REST call. So in my personal opinion, once you start understanding that the SOAP based API, REST based API and GraphQL, then you can actually make some quite interesting, very complex applications or systems, and in a very simple and powerful manner, in a very scalable manner. So understand which one to use when. SOAP, very good whenever you are doing like any sort of financial transaction. REST, very good whenever you have a web application or mobile application that wants to provide its services to large number of users, and the use case is typically one-to-one, that one request for one answer, something like that. And GraphQL is that mostly REST based application, but for complex large queries of inputs. So understanding the concept of these 3 is going to be really key. Okay, now we need to understand these 2 terminologies in the really good manner, that is authentication and authorization. Twitter API is not going to allow anyone to access the Twitter services unless these 2 things have been established beforehand. And if they are not established, then there can be a lot of issues, because think about it, Twitter already has your user ID, okay? And on top of it, it already knows that what are the posts you are making or what are the changes you are doing. What if that I am a bad actor and I want to make changes to your Twitter handle? What I can do is I can simply make an API call and I can say that, hey, for this particular user ID, create this post or create this tweet, and then that tweet would go public, and then there would be a lot of issues or a lot of confusion. So that is a bad scenario. So in this case, what typically Twitter would do is it would first check that who the person is that is claiming to make changes to this user ID. Does that person is originally that person who says that person is? And if that is the case, then only allow that person to make changes. And that is where authentication comes into place. Now we all have done authentication and there are various mechanisms to do it. So number 1 mechanism to authenticate a person is using user ID and password. So typically this is what happens when we try to log into our Twitter application on mobile phones or on websites. In either case, we are providing our credentials. On top of it, many times we have to do two-factor authentication or multi-factor authentication to validate that we are the correct person who say we are. But they all are part of authentication. Now, this is not the only thing. There is also something else called API token. What API token is typically, that API token is the combination of this user ID and password, and it is going to be unique for this particular combination of user ID and password as well. So whenever you provide your API token rather than providing your user ID and password all the time, even with the API token, Twitter can validate that, okay, this person is the correct person, and now let me let that person in and make all the changes. So that person is now authenticated to use Twitter services. There is also another way, and that is called OAuth. Now OAuth is slightly more complicated. What OAuth does is, in order to understand, we will first have to understand whenever we want to use any services. Let's say that I created an xyz.com. Now for this xyz.com, I actually have two options for signing up new user. Number one is that user can actually sign up for xyz.com, where inside my domain I'm going to create a new value for that particular user ID and that particular password and allow access for that user. There is also another option where in my existing website I can actually say that, hey, if you have a Google account, if you have a Facebook account, or if you have a Twitter account, I can mention, or I trust these companies that their users are going to be legitimate and valid. So I can also let you log in using Google, Facebook or Twitter account. Now in this case, these items becomes identity provider, and through using their identities, I can actually create and give you access to my xyz.com and treat you as one of my users as well. But the thing is, in order to do that, I will first have to validate these tokens. So what would happen is that whenever a user would try to use Google services, Google will actually say validate that person on my behalf, on xyz.com behalf. And then once the validation has been completed, Google will send me an OAuth token. And all I need to do is validate that OAuth token. So that OAuth token is actually the combination of user ID and password that user has for his or her original Google account. And that OAuth would be validated, and that can also be one of the authentication mechanisms, and through that we can actually let the people in for our Twitter API. So this is the part of authorization, which means making sure that the person is he or she claims to be. Now authorization is different. Authorization is basically that after you have been authenticated, what type of access do you have? So this has something to do with role-based access control, RBAC. And how this has been established is, let's say that my user ID name is Parth. So all I can make changes in the Twitter API is for Parth's account, nothing more than that. I should not be able to make changes to Brad Pitt's account because I am not that person, and I don't have authorization to make changes to that person's account. So in this case, role-based access comes into the picture, and all the cloud providers or on any particular on-premises services have this access of role-based access control. Now, same way, think about it, that what if instead of me, there is Elon Musk. Now, Elon Musk is currently the owner of Twitter, which means Elon Musk is going to be authorized in order to make changes to the Brad Pitt's account and also my account and also his own account. And that because he has higher level of authorization. So this is how authentication and authorization works for any particular API. And from the server's point of view, server does not care. Server is trusting that the previous API management mechanisms we have that is dealing with all of these APIs, that has already taken care of all of the user authentication and authorization, and only the valid requests are actually coming with the server. Now let's quickly understand some of the best practices with APIs. So number one best practices whenever you are developing or designing your API is to put a rate limiting mechanism. Why we have rate limit mechanism is because so that the servers does not get overloaded, because many times for our server, because we have exposed all of these APIs through bunch of different people, anyone in the world, essentially what some bad actors can do is they can just keep hitting this API over and over and over again, something as called as DDoS attack. So denial of services. In this case, they try to basically bring down the capacity of the server or crash the server completely. So there can be an issue. So if you have rate limiting in place, you are essentially allowing any particular user to call, let's say 5 times in 1 second, nothing more than that. So that way you are actually reducing the capacity that anyone can make calls to the services. Second one is the error handling. Let's assume that many times like incoming request comes in with a flawed data, or the request parameters are not satisfied. In this case, you want the server to return back the response in some appropriate response code and saying that, hey, these were the error with your original request. So either provide me a new request with the correct data, or stop calling me, or stop bothering me. Next one, you will have to think about authorization and authentication. So authorization, I already explained a lot of different techniques, and authentication, there are also mechanisms to implement the authentication using role-based access. So you can do a lot of things with that. On top of it, whenever you are designing APIs, there are a lot of inbuilt tools available to us. So tools like APG or API Manager or API Gateway. So they can actually do a lot of different things on with APIs. So always make sure that when you can, try to use some API gateway to manage these APIs, and then that way you can actually set up firewall rules, you can set up domain name services, you can set up or distribute load according to various servers and call different services, validate different services in the mechanism. So always make sure to use these tools. Now let's see a quick demo. So now let's see an example of an API that I created, and then we will see some public API. Now this is a very simple API where I am opening or creating a Spring Boot application that I'm building using Maven. And if we see inside the REST controller, we only have a get mapping method, that is add. And in the input parameter, I'm requesting parameter number 1 and parameter number 2, and I'm simply doing some of these two parameters and returning that. Now let's see that how would this API would work and how it would look like. So let me first try to run this application. So if I do that, let the Spring Boot start up, and we can see that the Spring Boot application has started correctly. Now I'm going through a tool called Postman, and in the Postman we actually have the ability to call bunch of different APIs, whether it's a local host or some outside URL. So in this case, I'm going to use HTTP GET method because this is what I created the API for. And as you can see, I'm making a REST call to an HTTP request, not an HTTPS, because I haven't secured it at the moment, and it is currently running in my local host in 8080 number. Now you can see I'm adding couple of variables inside the input, and the variables are number 1 and number 2, and I have the value /add because in my code I'm defining that the mapping for this API is defined as /add. So whatever your URL is, like www.whatnot, and in the end it would be /add that would call basically this piece of functionality. So now let's try to run this code. And if I make a call, we can see that in the answer it simply says sum is going to be 80, and in the input parameter I'm passing the value number 1 as 77, as it can be seen over here, and number 2 as value number 3. If I change these numbers to something else, let's say 5 and value number 6, the answer should be 11. So if I do that, I get the sum as 11. Now we can see that in the answer we are not only receiving the sum value, we are also receiving bunch of different headers and few other values. So let's analyze these headers. Now in the headers we are seeing that the content type that is coming in, that is in the text or plain format. These are a few other parameters that keeps track of when the transaction occurred and when it was sent. The important thing over here is that the status, that is HTTP 200, that defines that the call went successfully and it was okay. And then we have that how long did it took for the whole flow of transaction to go through, and what was the size of the bits transmitted. So this would be what the answer would look like in this scenario. And also we can see that in the input we are sending out bunch of different headers, so they are hidden over here, but we can unhide them and we can see that there are a lot of information. Now since this is locally running, we are not authorizing any element, but there are a lot of different ways to authorize your incoming request. So you can use API token or bearer token, OAuth calls, and there are a bunch of different methods provided to you, and that is usually defined within the definition of API. Now we saw that how to create and run a local host API. Let's try to connect with some of the outside entities. So this is a website called jasonplaceholder.typecode.com, and this website is typically there in order to test out your JSON placeholder and codes like that. So this good thing about this application is it does not require any authentication. So in the authorization, I'm not providing any value. And first, let's try to make a simple HTTP GET call. Now in the GET call, I'm simply trying to see all the posts that are available on the JSON placeholder.typecode.com website. Now, if you want, this is also a real website. So first let's go to the website and see. We can see that this shows all of these different scripts that are currently present, and these are the various posts or various APIs that we have access to, where we can get the information about all the posts that are there. Let's try to click one of the posts, and if we click there, we are seeing a lot of different posts that have been created for any particular user. Same way we can get comments and the comments that who wrote what and things like that. So we are just making a call to this post API, and once again we are seeing bunch of different results. Let's say for an example, we try to make call to the post one comments, and you see when I make the change, currently there are no parameters included because this is just the API URL, nothing more than that. And let's try to send this, so we get this answer. Now for the same website, we would try to post some of our own comment, and we would try to make an HTTP post call. Now when we are making HTTP post call, we are actually adding some information on the existing website, which means we will have to pass in the data we are trying to add. And that's where this body component comes in, that in the body we are trying to insert these values. So the title should be foo, the body value should be bar, and the user ID should be 1001. So let's try to add this. So if we send this, we get this response, and this time in the response the status code is HTTP 201. Why? Because the request type was post, and in the status it says that we created a new entry on this particular website, and this was the result being sent back. And we are currently seeing this in the JSON format. If we were to see in the XML format, it wouldn't look very good because this is inherently just the JSON format, but you all know how an XML looks like. And same way, let's try to put in the call. So now we are updating any existing data. So in the put, once again we are using HTTPS put call, and let's see in the body we are trying to update the user ID. So let's just mark it as 1001, and let's send this. So see, we got the HTTP 200 saying that the response was okay, and we got the correct value updated in the backend, and we received bunch of different headers with this connection as well, because this is a live API. So it has a lot of configurations, and it is sending back much more information than we originally had. Same way, let's try to get a post for some particular specific user ID. So in this case, we can actually see that when we select user ID as 1, it is actually selecting this information. Let's try to select user ID as 2, and now it will show up on this source. So this is a really good thing about Postman tool. And let's try to send the data. So if we do that, we get all the posts made by user ID number 2. If we change it to something else, let's just see user ID number 11, then we should get all the posts. So since user ID number 11 did not create any post, we are not seeing anything. Let's try to see for user ID number 3, and we are seeing bunch of different results as well. So this is how APIs are actually reshaping the world and making things much easier to handle.